BEA P NARO, a BSED Mathematics 2A student, and today I'll be discussing the Euclidean algorithm or number theory topic. One of the earliest and most significant mathematical techniques is the Euclidean algorithm. Around the 300 BCE, the Greek mathematician Euclid introduced it in his well-known work Elements. The greatest common divisor of two integers can be found quickly with this approach. The Euclidean algorithm is still highly helpful today despite its age, particularly in computer science, number theory, and cryptography. This talk will explain the algorithm's operation and the reasons it is regarded as a key idea in mathematics. We'll learn how to determine the Greek's common divisor or GCD today. So do you know what is GCD? GCD, it is the largest number that divides two or more numbers exactly with no remainder. So we will use the three easy method to solve it. First is the listing method. Second, the prime factorization. And the third is the Euclidean algorithm. So let's use the number 24 and 36 for all our example today. So first is the listing method. In this method, factors of both the numbers can be listed. Then it becomes easy to check for the common factors. So there are three steps for the listing method. First is to list out the factors of each number. Second, mark all the common factors. Third is choose the largest one. So, are you ready to solve with me? So, let's solve the factors of 24 and 36. So, do you know what is the factor of 24? Yes, that's right. The factor of 24 is 1, 2, 3, 4, 6, 12, and 24. So what is the factor of 36? Yes, you're right again. It's 1, 2, 3, 4, 6, 9, 12, 18, and 36. So the common factor of 24 and 36 are 1, 2, 3, 4, 6, and 12. So what is the largest? It's 12, right? So our GCD is 12. So this method is simple, right? Best for small numbers. So now let's proceed to our second method, is the prime factorization. So prime is a way of expressing a number as a product of its prime factors, starting from the smallest prime factor of that number. So here are the steps of prime factorization. First, divide both numbers by common prime factors. Second, multiply all the prime divisors. So now, let's solve the prime factorization of 24 and 36. So, what number can we divide for 24 and 36? Can you say it? Yes, correct. It's 2. So, the answer is 12 and 18. So, we can divide it again by 2. And the answer is 6 and 9. We can also divide it by 3. Yes, correct. So, the answer is 2 and 3. So, there is no more same factors. So now, let's multiply them. 2 times 2 times 3 is equals to 12, yeah, right, it's 12. So our GCD is 12, yes. The faster in need for the biggest number. So, third is the fastest method. So, the third is the Euclidean algorithm. Euclidean algorithm is the method for efficiently finding the GCF of two numbers. It involves repeatedly dividing the larger number by the smaller number and taking the remainder until the remainder is 0. So, here is the steps. First is divide bigger number by the smaller one. Second, use the remainder as a new divisor. Third is repeat until remainder is 0. Last divisor is our GCD. So, let's solve for 24 and 36. So, 36 divide 24 is equals to 1. Remainder is 12. Yes, right. Now, divide 24 by 12. 24 divided 12 is equals to 2. Remainder is 0. So, last divisor is 12. So, our GCD is 12. The best method for every large numbers. Yes. So, did you guys notice something in our discussion? Yes, all three methods give the same answer. Their GCD is 12. So, first is the listing. Listing is the easiest for the beginners. Second is the synthetic prime, systematic and clear, and Euclidean is the fastest of all. So, remember, take note, no matter which method we will use, the GCD will always be the same. So, that's all for today. Thank you, everyone.